Have you ever felt completely stuck? You're struggling with something that just seems to come so easily to other people. We're always told to look inward, right? To find that personal flaw, that lack of willpower. But what if the answer isn't just inside you? Today, we're going to go on a little journey, zooming way out from the tiniest spark in our brain to the massive systems we live in. We're going to explore the invisible architectures that really shape our success and our struggles. And it all starts with a simple but really profound question. So when you hit a wall, is it really a sign that you failed? Is it just that you're not trying hard enough, or you're not smart enough, or maybe you're just not organized enough? This is the story we tell ourselves all the time. But what if there's another way to look at it? What if those struggles are actually the product of these hidden systems, or, as we're going to call them, architectures, that we're all operating inside of? Just think of an architecture as the underlying blueprint. It could be biological, psychological, or social, and it's got its own set of rules that we rarely ever see, but we definitely always feel. To really get this, let's zoom all the way in. I mean way in, to the most fundamental building block of our entire experience, the neuron. How does a simple little electrical signal turn into something as rich and complex as sight or a thought? Well, the answer reveals that very first layer of architecture. Okay, so we often think of our neurons passing messages like it's a simple relay race, right? A signal hits the end of one, it zaps across a tiny gap called a synapse, and boom, it kicks off a new signal in the next one. But you know what? It's so much more complicated than a simple handoff. That gap, it isn't a bridge, it's more like a checkpoint. And at that checkpoint, a really crucial decision gets made. So a single neuron is getting bombarded with thousands of inputs. Some are screaming, "Go, fire," while others are whispering, "Nope, stay quiet." It then does this kind of neural math called summation, where it just adds up all those competing voices. And here's the kicker. A new signal only gets sent out if the total input crosses a critical threshold. If it doesn't, the message just stops. It dies right there. This isn't just a routing system, it's a filtering system. And this is a perfect example of how that filtering literally builds our reality. You see, lower-level neurons, they fire for simple stuff. A line here, an edge there, a little patch of light. But the higher-level neurons, they only fire if they get the right combination of signals from below. So a few edges become a curve, a few curves become an eye, and the right combination of eyes, nose, and mouth finally crosses the threshold for a face neuron to fire. See? The brain isn't just passing along data, it's actively selecting for patterns that mean something. That's our first invisible architecture. So, this idea of filtering, it brings us to our next level. Let's zoom out from the biological to the psychological, because we see this exact same principle at play. If our brain is an architecture that filters signals, what happens when the very process of thinking itself creates its own kind of friction? Cognitive scientists talk about two different kinds of mental effort. First, there's germane load. That's the good stuff. The actual work of understanding an idea, making a tough judgment call, or having a creative breakthrough. But then there's extraneous load. And this is all the friction. It's the mental energy you burn just trying to format a document or remember some 10-step process, or just wrangle your thoughts into a neat little outline. This friction doesn't help you think. It actually gets in the way. And here's the thing, this friction isn't spread around equally. For a lot of neurodivergent people, we're talking those with ADHD, autism, or dyslexia, for example, the architecture of our world creates a massive amount of this extraneous load. All the energy that could be going into brilliant creative thinking gets completely exhausted just trying to manage the interface of a system that wasn't designed for their brain. The problem isn't a lack of intelligence, it's a fundamental mismatch with the architecture. This completely reframes how we should think about support, and that includes technologies like AI. The goal is not to do the thinking for someone. No, it's to absorb the extraneous load, to get rid of the friction so that a person's full cognitive power can be aimed at the actual work of thinking. It's about clearing the path, not walking it for them. Okay, let's zoom out one more time. We're going from the individual mind to the social systems that we all live and work in. If friction can block an individual's thoughts, what happens when it blocks their ability to even participate in the world? There's a new framework called coordinative access theory that gives us a really powerful lens to see this. The first big idea here is something called expression cost. This is basically the price of admission for your ideas. It's the total energy, cognitive, social, technical, all of it, that it takes to translate a thought inside your head into some external form that other people can actually understand, like a report, a presentation, or even just speaking up in a meeting. And when those expression costs get too high, We get this latent competence. And this is such an important idea. It's all the brilliant ideas, the insights, the capabilities that are locked away inside people but never ever see the light of day. They're not lost because someone isn't capable. They're lost because the cost of getting the idea out is just too damn high. The architecture itself creates a barrier. And this brings us to the core argument of the whole theory. It suggests that who gets to participate, who gets seen as smart in our society, it has way less to do with their actual innate cognitive ability and way more to do with whether they have access to the tools and systems that lower the cost of coordination and expression. So that leaves us with a pretty provocative question, doesn't it? What if we've been focused on the wrong thing this entire time? What if the primary barrier to progress, to innovation, to equity, isn't some deficit in people's ability to think, but a deficit in our system's ability to let those thoughts be heard? Because when these invisible architectures create all this friction and block people from participating, they don't just cause frustration, they create stress, a lot of it. And the way a system handles that stress reveals its most hidden and often its most toxic architecture, the architecture of blame. And this is such a powerful insight. Blame isn't always some moral failing or a logical conclusion. At a deep nervous system level, it's actually a strategy. When stress builds up in a system, a family, a team, whatever, and there's no safe way to share it or process it together, it has to go somewhere. Blame gives it a target. It's a release valve. And this strategy can point in two different directions, right? Outward blame, this is your fault, is an attempt to offload that uncomfortable feeling onto somebody else. But inward blame, or self-blame, this is all my fault, is just the flip side of the same coin. It's a strategy to contain that stress inside yourself, usually to avoid conflict or rejection. Both are just learned responses to an environment where stress itself feels dangerous. This really just boils it all down. It reveals the fundamental difference between healthy and unhealthy systems. A healthy system has ways for stress to be shared and processed, allowing it to move through the group. But in a high-friction, blame-filled system with no safe outlet, that stress gets trapped. It has to land somewhere, and it inevitably lands in a person, either as an accusation from others or as shame from within. So, if our world is filled with all these invisible architectures of neural filtering, cognitive friction, systemic blame, what does a better one even look like? How do we start to build systems that are sustainable and, humane? In systems with tons of friction and constant blame, people eventually learn a really painful lesson. Caring is a liability. I mean, think about it. When pointing out a problem just gets you a pile of extra work or makes you a target, the only rational response is to check out. It's not apathy. It's a survival strategy taught by the architecture itself. A better architecture is built on this key principle, recoverability. It asks a totally different question. It's not how do we maximize output, it's can the system handle actual human life? Can it absorb mistakes and stress and change without permanently breaking the people who are a part of it? This just completely redefines what we should even consider a high-performing system. If a workplace or a school or any system consistently leads to burnout, it is not successful. It's extractive. It's literally consuming its most valuable resource, people, faster than they can possibly recover. Burnout isn't a personal failure. It's a design failure of the system's architecture. And that leaves us with one final, really powerful question we can use to look at the invisible architectures in our own lives, whether it's at work, in our relationships, or even just in how we talk to ourselves. Does this system preserve the possibility of return? A return to health after being stressed out, a return to contributing after making a mistake, a return to connection after a conflict? Because a system that allows for return is a system that allows for growth, and that is an architecture worth building.